Cool. So the first week of course 2 focuses on EDA and visualization. So kind of exploring data at the very early stages of a project. So and using visualization tools to kind of guide your modeling approach. The key learning objectives for the first part of course 2 is that you be able to explain the main steps in exploratory data analysis, explain the use case and the uses for the various Python tools that you use in EDA, describe the key strategies for dealing with missing data, and explain the role of communication in EDA. The key concepts that I'll be talking through are kind of my main takeaways from the lesson. Yours may vary, but these are in some ways kind of meant to be a little bit of a cheat sheet for folks that want to kind of quickly get caught up, or for a future SAM, as I kind of want to refer back to what I've learned in this course. The first part of the week talks about exploratory data analysis. The reference, I never actually thought about the kind of the contrast between exploratory versus confirmatory data analysis. But the main idea there is that, with exploratory data analysis, you're not yet at the point where you're trying to confirm or disprove any particular theory. You are exploring the data and following hunches and trying to use that exploration to learn more about the data set and what might be happening in the data set to guide you towards solving your problem. There was an interesting mention in the course that sometimes all you need is EDA and visualization, and through thoughtful exploratory data analysis, you can come across a solution to a problem that kind of obviates the need to actually go ahead and create a model. I can imagine a number of scenarios where that might be the case. Maybe you're trying to figure out how to grow your business, and you find something in, through your exploratory data analysis that says that you shouldn't be in that particular business or in that particular country in the first place. And so, you've saved, or you've kind of eliminated the need to cut off, or sorry, to go through the later stages of the AI workflow based on something that you've learned in just exploring and understanding the data better. And so the big challenge, or one of the big challenges with EDA, is that you've got a ton of different options in terms of how your data can be visualized, the different tools that are available to visualize your data, and how you communicate the results. And this is the way the course articulated the challenge. I think furthermore, because it's kind of exploratory, it's a scientific process, and it's also very difficult to to state how this process needs to go. You're kind of playing with the data, again, coming up with hunches, following hunches, running different, formatting the data in different ways, visualizing it in different ways. Sometimes it's difficult to know, when to stop, which direction to go in first. And I think the key is to just play with different options. I haven't seen any in this course or others kind of a cookbook for EDA, and I don't know that one could exist. But we'll come back to this. One of the ways that the things that you can do to help is to kind of learn the tools well, or at least a tool well, and what some of the things that they are, or your tool of choice is capable of. But we will come back to tools in a second. Any questions so far? All right, so notwithstanding, what I just said about kind of processes or cookbooks for EDA, the course does present a high-level process or workflow for EDA. Essentially, you start by ingesting your data, and then you perform your exploratory analysis. The key points that they emphasize are the role of summarization, using the various summary views of the data to tell a story or elucidate a story, identifying where you might have missing data and appropriately dealing with that missing data, and then using what you learn to kind of plan further investigations. And all of the output of EDA per the course is a communication. The course refers to it as a deliverable, something that is meant to spark discussion, further discussion, as well as help you make decisions about both your problem or project, as well as kind of where to go next in your exploration and modeling. And so to be a little bit more concrete, they present this example where in your data ingestion, you're loading data into pandas, NumPy, or a similar tool, and doing different types of summarization steps. You're using a combination of tables, text, and visualizations to tell the story, or tell a story that relates the business opportunity to the data. So what is the data saying about the problem area that you're trying to explore? You're identifying a strategy to deal with any missing values that you find in your data. You're investigating the data and in the context of the underlying business scenario or problem with various visualizations and testing hypotheses. And ultimately, you're communicating your findings. In terms of the communication, it's you're not just communicating the results of what you found, but also they emphasize a lot of this is making sure, kind of referring back to the, maybe I'll take a step back for folks that are just joining the sequence. The first course mentions this process called design thinking, which is in many ways, if you're not familiar with design thinking, but you are familiar with agile type of development methodologies, design thinking is kind of a more generalizable or generalized type of process that can be applied to areas as diverse as marketing and other types of project management, as well as data science and software development. And one of the steps in the design thinking process is when you are communicating or presenting with your stakeholders, and that's called a playback. And so they emphasize here in that context that you're not just playing back your results, but also what you've done so far and what you're currently doing and what you plan to do. So the idea is to create more transparency in the process for the various stakeholders, so that folks generally know, where things are going and can offer input and, help you understand their priorities, et cetera. Any questions on the EDA process so far? The other thing that was mentioned quite a bit in the context of communication that I'm not really going to cover here, but you can find in the course materials is a lot of references to ways that you can go from notebooks and notebooks in particular to slides. There are some interesting tools that will allow you to create slides directly out of your notebooks. And in fact, one of the videos in the course uses one of those tools. Speaking of tools, we do spend a fair amount of time talking about tools. And there are some pointers to an interesting series of blog posts, a couple of years old now though, but still relevant, I think, from Anaconda, talking about kind of the breadth of the Python visualization landscape. This course tends to emphasize the matplotlib family of tools, and in particular, the examples use matplotlib and Seaborn quite a bit. But any of these tools, there's a lot of overlap, in this tool ecosystem, and I think the key is to have some standbys and know kind of what some of the how you can use them, and you can use them well, and kind of matplotlib, Seaborn, pandas are as good a starting place as any. And so some tips that I gleaned from the course material around plots are kind of referring back to the point that I mentioned in course 1, week 2, about first get started, then make it better. The idea here is to make it as easy as possible to explore the data and kind of iterate quickly in your exploration. And so they really emphasize keeping plots quick and dirty, and distinguish between dashboards and plots. Dashboards are kind of hardened visualizations that are meant to provide for long-term communication to stakeholders, whereas the kind of plots we're doing in EDA are quick ways of getting through the data and exploring different possibilities. As in the first course, where we built the data ingestion pipeline, and then they emphasize at the end of that, okay, now get it out of a notebook and put it into code so that we can both ensure that we can run it consistently as well as version it. The same thing is true for notebooks, and they emphasize that whether you're using one of these notebook to slide tools or using your notebook to present your data, to keep things clean from a presentation perspective, as well as to be able to version your code. You want your visualization code to be in separate files as well. And then, my own, I kind of mentioned this on the last slide, but I think for the purposes of these projects, and, even projects in general, it's, totally fine to get through these projects via, copy and paste. When I'm working on these projects, I am doing a ton of Googling to try to remind myself how to produce a particular type of chart, or how to get the data in the format that I want it to be in. But if you're working on this stuff regularly, it is very helpful to, again, identify some core tools that you want to rely on, and then dig into the docs, at the very least, so that you understand what's possible and kind of how all the pieces fit together. Any thoughts or questions on plotting? Does anyone have any additional tips on this, or interesting tools that they've come across in the kind of plotting and visualization domain?
I have a question, and I don't know, just to get people's thoughts, if anybody has thoughts on this. But the EDA part of data science projects, when you are working with a team, and it could be even a small team or an informal team like Kaggle competitions or anything like that, how is that best structured? Because I've seen sort of mainly the scattershot approach where everybody goes off, does their own EDA, comes back. We all have pretty much, similar things, which is great for that verification, but it does feel like we've really kind of just duplicated that work. So is this something that's typically in a team environment in enterprise would be a single person works on this, reports back, or are you dividing up the EDA in some kind of way? I'm just curious how that's managed, if anybody has done this kind of work in an enterprise team environment.
Does anyone have any thoughts on that, or practices that they can share? How do you do it in your own teams?
I think something we've done in the past on teams I've been on, which isn't entirely exploratory because it has a little bit of sort of hypothesis-driven approach to it. But what teams I've been on before have done that's been very effective is more of a like really understand the business, right? Whatever business or question or it may be, and understand, talk to the people who've worked in it for a long time, understand what are the key drivers, what factors impact the business, and then take a little bit more of a hypothesis-driven approach to saying, okay, well, given that, now let's take this massive pile of data and split it across the team. So someone looks into one particular aspect of it, someone else into another, someone else into another, and then come back and report to see what it is that we found that would be useful. I know it's not truly 100% exploratory, but it's been very effective at getting to insights quickly in my experience.
Cool. Any other thoughts? Anyone else have something they can share on that? I think another thought is to kind of, as you suggested, just kind of divide and conquer. I think, as I was going through the project and kind of reflecting on, the EDA phase, I think I think teams can be very beneficial because you can kind of bounce and iterate, off of ideas and combine ideas, and one way to avoid that duplication of effort is to maybe brainstorm, in a Google Doc or something, things to try or things to look at, or, well, maybe, we should look at the, whether the, the gender impacts the churn rate, or maybe we should look at the, if the number of streams impacts the churn rate, and come up with kind of a long list of, these things to look at, and then, maybe take a step where you kind of categorize them or sort them, or kind of group the related avenues of exploration, and then kind of divide and conquer in that way. it kind of raises Jose's point whether, is that hypothesis driven or, exploratory? It's a good question, but it can allow you to get the benefit of kind of the team dynamic without overly duplicating data, or duplicating not data but duplicating efforts.
Yeah. So that's, now I'm starting to see how that could be designed as something that team members could choose which of those components they want to focus on. So yeah, so those are good ideas. Thanks.
Cool. So in terms of summarizing data, the course spends some time talking about the use of group by and pivot table to summarize data. And these are both used and required to kind of get through the project. And there is some discussion as well of approaches for discretizing continuous data using Q-cut and cut. We'll maybe pull up the project and can show some examples of group by and pivot table. They're very similar in functionality. There's a link in the course materials to a document that describes the differences between them. But the way I kind of think about it is that group by is a little bit more quick and dirty, and then pivot table is more powerful and gives you a little bit more functionality and or flexibility in kind of the API or the way you use it. But essentially, they're allowing you to, create, pivot tables and look at, different columns of your data based on other columns of your data. And then discretation. The discretation is like the way you can create bins for your continuous data. So, for example, if you've got an age field, you might want to bin that in terms of, ranges, 0 to 10 years, 10 to 20 years, etc. And cut and Q-cut are used for that. Q-cut is for quantile based binning. So you can think of that as, actually there's an exploration in the course that's based on this happiness data set. And one of the things that you do in that data set is there's a happiness score, and you bin that, into 4 or 5 different categories, not very happy, or very, very unhappy, unhappy, happy, and very happy. For example, if you do it in quarters, and you can use the Q-cut function to do that. And so summarization is a big part of the EDA process, and kind of looking at the data from different dimensions. Anything to add here? So the first, so this week is broken up into 2 main topics. The first, and what you spend the most time on in the case study, is EDA, but there's also a fair amount of content on missing data. We don't necessarily dig into that in the project yet. That may come up in the second week's project or a future course. But in terms of missing data, there are 3 types of missing data. What's called MCAR, missing completely at random. There's missing at random, Uh, missing completely at random means the data, there's no kind of clear dependence on the missing data and the your existing variables. Missing at random means there is some dependence, and you can use that. You can potentially use that dependence to impute missing values. The example that they gave in the course is if you are surveying people at there was an ML Major League Baseball survey or something. They use the example that you might find that some questions are unanswered or answered based on gender, and so you can use that dependence to impute missing values. And then there's missing not at random, and that is where your missing data depend on unmeasured or unknown variables. And so the way you deal with missing data depends a bit on why the data is missing and the type of missing data. Your general strategies, they were explicit to say that, hey, one of your strategies for dealing with missing data is to ignore it. And the problem with that is that a lot of the models and model training techniques are not designed to ignore data, so they're going to try to create meaning out of this missing value that might not be what you expect. There's another popular approach is what they call complete case analysis. And you can think of complete case analysis as meaning we're only going to consider data that we've got a complete record for. So in other words, we're just going to drop rows that have missing data in them. And in fact, in the first case study, one of the things you're doing is you're basically looking in your data set for missing values, and if there's a missing value, you're just dropping that row. Now you need to be, you don't want to be so indiscriminate about it. For example, in that first case study, there is a state field, and that state field was not set if the country was not in the US. So you need to be discriminate about that, but you can use the drop NA function in pandas to do your to drop rows with missing data. They also mention columnar complete case analysis and using drop NA on the columns axis. But they do make the point that once you start to drop columns, entire columns, you're kind of getting into feature engineering territory. So beyond ignoring your missing data or only dealing with complete records, the next strategy is to try to impute some of your missing data, and I'll talk about that on the next slide. But before that, they, going back to this design thinking process, the very first step of that process is focused on empathizing or empathy. They use that in the data science context to mean both understanding your stakeholders and the business problem that you're trying to solve, and understanding that deeply, but also understanding your data and the generation process for your data. And in this context, what that really says is to try to get at the root of what is causing the missing values in the data, so that either you can fix that, or maybe gain some additional insight into what those missing values mean, and other what the correlations might be with some of the data that you have, and using that to guide your approach to dealing with it, or your imputation strategy. Any questions on the dealing with missing data so far?
This may be a silly question, but where you've got your df.dropNA,
Yep.
access equals columns, is that a missing single quote, or is that a special character?
No, that's a missing,
Okay.
that's a missing single quote. Yeah.
Okay, great. I was like, ooh, what does that do?
Yep. All right, so cool. Imputation. So imputation is when you replace missing data with substituted values. And so they talk about a few different types of imputation. I guess simple imputation, which isn't here. Bayesian imputation, which they kind of mentioned but don't really go into details, and multiple imputation. A good example of simple imputation is when, if you've got a continuous variable like age, and you've got some records where age is missing, you can just use the mean of the values that you have for the missing age values. And so the idea being, if you leave them zero, either something breaks, or maybe you're counting it as zero, and that will skew your overall mean. But if you just use the mean, you can will not skew your mean, and you can complete your analysis. And then multiple imputation is the idea that if your missing data is correlated to multiple columns, then you can use all of those columns in figuring out the way to impute your missing data. There's a little bit of conversation about that in one of the videos in the section, but there's not a lot of kind of detail on how you do it in the project or in the readings. They do mention that the strategy that you choose is based on the type of data that you have. So if you've got categorical data, it is often best to treat missing data as a category in your categorical data. So for example, you can create a non-specified or missing category and just treat that as another category of that field. If you got numerical data, though, it's better to use an imputation technique like the mean that I mentioned. But if you're worried about kind of losing information and losing track of where you had missing values, you can create a new column for that with a flag for where you've imputed a value or where you originally had data missing. Ultimately, these imputation strategies, the ones that you use, or how you apply imputation, can change the performance of your models. And so the best approach is to consider this in your model evaluation, and to evaluate the different strategies on a holdout set. And so they kind of end the discussion of imputation here in the EDA section by saying that You may want to choose something simple in your EDA, but you want to be sure to reconsider it later on once you get into the feature engineering and modeling loop, because they will impact, or they will potentially impact the performance of whatever models you build. Any questions on imputation?
I guess I'm just wondering how, if anyone in the group has any experience or insight into how this is handled in the real world. I haven't done too much big data modeling myself at work or anything, so I don't know how people handle this in the real world. I just think back to my more statistics classes where we frequently would do you'd flag what was missing, and then you'd run some analysis with the full set of data, and then some only with that data which you had all the values for, and compare whatever it was that you would compare, whether it was an R-squared or a p-value or an F1 score, whatever, and determine which model was more likely to be effective at predicting whatever you're trying to model.
Mm-hmm.
What about in the real world? Does anyone have any thoughts, or do you have any thoughts, Sam, on how do people handle this in the real world of big data?
Yeah, I'll let anyone chime in.
My first thought is that it would be surprising if there's not a library that in some way kind of does imputation differently, and then somehow evaluates the results of the different ones, and then kind of tells you which might be the best approach. But I've mainly seen just sort of, you're supposed to have the statistical chops to be able to know which one of these to do, and then just take it and go forward. And for extra credit, somehow maybe, check and validate that was effective.
Yeah, in terms of libraries, they do mention sklearn has a iterative imputer, and there is actually a fair amount of discussion in that I did not include in here. But the idea is that you can almost like do a grid search over. You'll have some hyperparameter of your imputation. And I forget the specific context of this, but this iterative imputer, because you're thinking of it as like something that you need to optimize, it will kind of run your model against the different versions of this iterative imputer. I'm sorry, of your whatever your hyperparameter is, and kind of tell you what the best imputation strategy is. And I can try to find that in the course materials. While I'm doing that, anyone else have any thoughts on or experiences with imputation? Let's see.
Well, thanks to both of you. Both, it's really helpful. And I will want to look into that, Sam, to see. I'll go back to the course materials and look for that area on the imputer as well.
I'm still here, but I got logged out of Coursera. It's not that one. Yeah, yeah, so there's under the missing data, let me resume my share. So under the missing data, there's a video on missing values. So often in this course, I found that the videos are just kind of, they repeat the stuff that's in the reading. to thus far, and so I had almost kind of started thinking maybe I would just skip the videos and go straight to the reading. But this particular,
and it must be a positive flow.
This particular video has a bunch of stuff that's not in the reading, and it's pretty good stuff. And so this is the conversation here towards the end of this video where they're using this this iterative imputer to kind of optimize the strategy. So I would definitely catch out this, definitely make sure to catch this missing values video in the missing data section.
Sounds good. Will do.
All right, cool. And then let's see, so we can talk a little bit about the project. The scenario here is that it's basically the scenario I mentioned earlier. You've built your data ingestion pipeline in the previous class, and now you want to start to kind of explore the data and try to get a sense for, are there indications of what might be the issue in Singapore, and how you might approach it. It is for, unlike the previous projects, it is very open-ended. Your instructions are basically, use your data ingester, kind of ingest your data, and then go ahead and figure out what's wrong. And so you do that by doing different types of summaries. So again, your kind of pivot tables and your group bys come into play. And you are just kind of playing around with the data. So I'm kind of partway through this. I didn't have as much time as I'd like to spend with it, but started doing some different exploratory analyses. Who here has started this project? Anyone?
Started it, but haven't finished it.
Yeah, I mean, so one thing that occurred to me is, for this project in particular, it might be one where it's interesting to, if folks were interested in doing it, to kind of take an approach like, where we, either work on it collaboratively or, brainstorm some ideas for things to try to graph or summarize. And support each other that way, or we can kind of talk about it, talk about it a little bit more now and kind of reconvene on it next time. What do you all think would be helpful in terms of discussing the project? Or we can pull up the solution and kind of step through the solution. Any thoughts or takers?
I'm happy with any of the above.
I'm good with any of the above also, but maybe walking through the solution and then talking about alternative things that could be done maybe would be a structured way of doing it, but I'm up with whatever.
Yeah, that's a good idea. Let's do that. So this is the solution. Quick note, when you download the zip file, there are two files. One is called M2U4 Case Study Solution, and one is called M2U4 Case Study Solution Edited. M2U4 Case Study Solution is actually the case study that is the blank template, and the edited file is the solution. I think I've got that correct. If not, it's the other way around, but you'll want to rename those files so you don't confuse yourself like I did. And so this is the solution. So they basically, for whatever reason, replicated the whole first lesson in here in the notebook. So everything up to this investigative visualization is basically replicating the ingestion pipeline that you already built. I'm not really sure why they did that. The approach I took was basically import everything and run the ingester that they had us build last time, and that they also included in the zip file. And then just look to make sure you have everything. I also went into the ingester. It kind of occurred to me that we didn't include gender in the data set, the target data set that the ingester pulls out, and I was just curious whether that might have had some kind of implication. So I went into the ingester and added that back into the target data set, but they don't consider it in the solution. And so this is all kind of stuff from the course. Basically, we're trying to figure out what's going on in Singapore. The first thing they do is they do a crosstab between the subscriber and the country columns, excuse me. And so basically what we're seeing here is that Singapore is kind of messed up. They have a lot more non-subscribers than subscribers, and many fewer subscribers than the US market. And so then the next thing they do is they do this looks like a count on number of customers, customer ID, between is subscriber and not. And this is for the total data set. So they're just looking at kind of the class balance between subscribers and non-subscribers in the total data set, and conclude that this isn't really going to help us so much. Then here they're looking at the based on country, the subscriber, non-subscriber balance by country. They're using this melt function here, where they're kind of rearranging the, oops, you can actually do a, actually I don't think this will work because I haven't run this, but let me try it. Yeah. Let's maybe try it here. All right, so basically what Melt is doing is that it, these are your customer IDs, and it is saying for, actually it's not clear to me what this is doing. ID versus, I'm not sure why they're doing this and not just subsetting this with these three columns. But we can see. Oh, oh, am I doing that right? Oh. So that is, I'm doing that wrong. I do a lot of kind of Googling when I'm doing pandas because it is super rusty for me. But I think this melt thing is, and maybe they're using melt just so that they have this x-axis. I probably have found a different way to do this. And I think I do something similar here, but conditioned on whether it's a subscriber. But that's the thing, there's like a gazillion ways to do each of these things. But the bottom line here is that they find what we saw in the numbers earlier, that there are a lot more subscribers in the US than Singapore. Anyone know more about this melt and why they're doing it, or have another take on why they might be using it here?
Looking on Stack Overflow, it looks like melt is just used to reframe or reshape data frames.
Yep.
I'm not sure exactly what the reshape they're doing is. I think I'd have to play with it, but yeah, I think that's all it does.
Yeah, no, that is correct. And what it's basically doing is it's just keeping this country, putting this country column in here, and I think they just do that so that they can then do a chart that has that as the x-axis without kind of manually specifying it. Kind of setting that up as the x-axis value. But yeah, it was kind of weird. They definitely do some things in the course that are counterintuitive, and for which there are simpler ways to do it. So let's see. So this one is looking at, so it's creating a pivot table based on the country and subscriber type, and counting the number of subscribers. So we see that the number of unlimited subscribers in Singapore is really low compared to premium subscribers and basic subscribers. So from this, we understand that basic subscribers in Singapore are more prone to churn out. I did something similar here. So looking at it for both non-subscribers and subscribers in US and Singapore, and kind of gathered something very similar, that US churned out customers. They churn kind of equally across subscription types, whereas in Singapore, they tend to lose their, the more someone is paying for, presumably they're paying more for these premium subscriptions, the more likely they are to churn. And also, Singapore has much more basic subscribers than the US, and much fewer of the premium relative to basic. And for me, this was just a simple pivot table there. And so now they are creating a factor plot, explaining the distribution of the number of streams among subscribers and non-subscribers. I think I did something similar in tabular form. I think I lost that in this version of the notebook, but you can do something similar by doing a pivot table and then plotting the pivot table. Their conclusion is that this isn't telling us a whole lot. So let's look at number of streams for different countries. And then they get a graph like this using here. No, okay, now we're using pivot table. Number of streams for different countries. And so they're basing it on age. So this information isn't enough. So let's look at it by age. And so here we're showing that seeing that Singapore subscribers are slightly older, and the U.S. subscribers were slightly older than U.S. subscribers, and around the same for non-subscribers. And so they're saying this gives us an important insight to analyze the average age for each subscriber type. And then so we're doing that now, kind of pivoting on country and subscriber type. So actually, let me pause here and for discussion, questions, and kind of alternate approaches or things to think about. Are we following? You all following along?
Yes, I'm following along.
Yep.
All right, cool. So, all right, so coming back to this, we're doing the same kind of age analysis, but kind of separating by country and the different subscriber types. And so we see that the average age for basic subscribers is more than 25, and for premium subscribers, the average age is approximately 22. And for unlimited subscribers is more than 25 in Singapore. From this analysis, we can infer that the average age for basic subscribers and unlimited subscribers in Singapore is less than 25. We also could have done this via a pivot table and doing a mean on the average age, but this kind of lets us see it by subscriber type. And so then we do a pair plot in Seaborn. This is gonna tell us a little bit about correlations. And then they do number of streams by country. The analysis shows that both number of subscribers and non-subscribers have approximately 15 streams. Probably not an important feature. So that I think here, you know, what the conclusion that they got to here, and this is kind of good to see because I think, you know, I know I personally went through this like looking for the silver bullet, like, aha, it's going to be X, Y, Z. But really what, you know, what I ended up with and what they've ended up with here is, you know, we've got, you know, we learn a bit about the data. We learned that there are more subscribers in the US than in Singapore. The number of unlimited subscribers in Singapore is really low relative to premium subscribers. The basic subscribers in Singapore are more prone to churn out. Earlier, the subscribers and non-subscribers have about the same number of streams in Singapore. The average age of both subscribers and non-subscribers is almost 25 in Singapore, and the average age for basic subscribers and unlimited subscribers in Singapore is less than 25. So this is kind of a, it's kind of a summary of what we've learned. And I think, again, I think you go into these efforts hoping that kind of in the EDA phase, like you'll have an aha moment, and sometimes you do, and other times you kind of learn some things that you can take into future analysis. And that is what we have found here. And they have some suggestions for future things that we can do to kind of go deeper into the EDA as next steps. So any thoughts or questions or discussion based on the solutions here?
I think it, as you said, there's not always an aha solution. It's more like in a business context. It's like, okay, what do we need to look to next? So for some reason, the Singapore market people don't want to be unlimited subscribers. Like, what is the reason for that? And then you have to look at content or the way you're marketing to Singapore users or whatever. There's also a huge difference in the number of users in the US versus Singapore. So there's some questions to be answered around there too. Mm-hmm. It does seem like there's, right, they say that the average age for unlimited subscribers is below 25. Well, there's probably some questions to answer there around, okay, is there something we can do to better market to people that are older than 25? And how do we keep people who are below 25 once they turn 25? Are they dropping off because their content preferences changes, or they're simply too busy because of work, whatever it may be? Like, there's a lot of questions you have to answer, but I think from a business perspective, but you need more surveys and other forms of data analysis to get there.
Yeah.
Yeah, I agree with Jose. I think that what's kind of nice about this case is that it isn't some really glaring, obvious aha moment solution. It's actually kind of, there's some subtle difference here that you have to dig into a little bit. And I guess maybe the first thing that comes to my mind is that these younger subscribers, they're not really seeing the value of the service. It's why they're not really signing up for premium right out the gate. Instead, they're trying out basic, and they're kind of going, well, yep, just as I thought, not particularly valuable. And then they're churning out. And so I guess as I look at this data, that's maybe something that I would want to dig more into is, even at the start of this, what's the perception of the product and the value of the different type of subscription?
Yeah. Yeah, I think it also kind of says to me that there's two separate aims that we can easily conflate, but they're kind of different things. One is, trying to identify like what's happening in structural and like systematic, issues that, and insights about the scenario. But there's also, what can we learn that, and on the first one, like insights about the scenario that like points to a problem. But the other are, what things can we learn that, can point to a solution. And so, for example, learning things about the relative, ages and genders and other things, maybe they don't tell us exactly what the problem is, and we can't learn from this data set, why, those folks under you know, or above a certain age are churning, but you know, they can tell us that, you know, maybe the sweet spot is folks that are about 25, and we can kind of launch a marketing campaign that targets them with the hope that they will be able to retain them longer, even if we don't fully understand that, you know, what's causing the younger folks to churn. And then, you know, as a separate takeaway, maybe that means that, you know, we should do some surveying of the younger folks to figure out what the issue is that they're, you know, running with. Maybe there's, you know, some other app that they all use that, you know, our app crashes or vice versa. And so they're just not able to use our app. It could be, you know, something that we're never going to find in the data. But this provides a launching off point for, you know, other things to look at. Cool. So that is the course 2 week 1 overview and case study review. We can circle back next week and kind of address any questions that you have after you've had a chance to go through this, or any additional insights. But otherwise, we'll be focused on estimation and hypothesis testing. So that's will be where we get to kind of formalize some of these ideas around what might be happening, and, you know, doing some testing. All right. Any other questions, comments, thoughts?
Nope, this is good. Looking forward to getting caught up and seeing what we do next week.
Awesome. Well, thanks everyone for joining and for your participation, and hope to see you next week and in the Slack channel.